Chapter 16, Thermochemistry. The basics of thermochemistry is the definition or the differences between heat and temperature. Because you know that thermochemistry, as you studied in thermodynamics in physics, thermochemistry is the study of energy, the study of energy transfer or the energy transfer among objects. Okay? So the first thing that you have to know, what does heat mean and what is the difference between heat and temperature. Heat means the energy transfer between two objects because of change in temperature. This is energy. The transfer of this is heat. The transfer of energy between two objects because of the change in temperature. But temperature is a measure of average kinetic energy. So if the kinetic energy increases, the temperature increases, or if the kinetic energy decreases, the temperature decreases. This is the first point. The second point that you also studied in thermodynamics is the meaning of the specific heat capacity. What does the specific heat capacity mean? Specific heat capacity, or CP, is the amount of energy, or the amount of heat, or amount of energy as heat needed to raise the temperature of 1 gram or 1 kilogram, according to the unit, of substance 1 degree Celsius. So this is the specific heat, the energy as heat needed to raise the temperature of 1 gram of substance 1 degree Celsius. The rule of CB, we know that if Q represents the heat or the amount of energy, so Q equals MC delta T, where M is the mass, M is mass, CP is the specific heat capacity, and delta T is the change in temperature, and the change in temperature in Kelvin is the same as the change in temperature in Celsius. Okay? The relation between Celsius and Kelvin is T Kelvin equal T Celsius plus 273.15. This is the relation between T Celsius and T Kelvin. For example, 15 Celsius and 10 Kelvin, the difference between them is 5. If you change 15 Celsius to Kelvin and change the 10 Celsius to Kelvin, the difference will also be 5. So the difference in Celsius is the same like difference in Kelvin. Example, calculate the specific heat capacity for object if the mass equal 4 gram and delta T equal 40 degrees Celsius or Kelvin. You know that if delta T, for example, if T initial is 314 and T final is 350, for example. So the difference between them is delta T. Here the delta T is 40, mass 4 grams. The amount of heat needed to raise the 4 grams 40 degrees Celsius, this amount of heat equals 32 joule. Calculate CP. So CP equal unknown. How can we calculate CP? CP equals, from this rule, CP equal Q over M delta T. CP equal Q over m delta T equals 32 over 4 times 40 equals 24 joule. Sorry, 0.2. 0.2. What is the unit of measuring specific heat capacity? The specific heat capacity is the result of heat over mass times delta T. So the unit is joule per mass in gram dot temperature in Kelvin. So this is the unit of measuring specific heat capacity. If you change joule into kilojoule, so the mass should be in kilogram. This is why the definition Cp is the amount of energy needed to raise 1 gram or 1 kilogram. Both of them right, based on the unit of Cp. Okay? But the specific heat capacity for each substance is constant. It doesn't change. For example, 4.18. For example, this is for water and so on. In this example, this is A. B, calculate the specific, the Q or the heat capacity for the same substance or the same sample if the change in temperature becomes 30. If delta T becomes 30, what is the amount of heat? What is Q? In this case, Cb is 0.2, so the same. If we are talking about the same sample or the same material, glass for example, glass its Cp equals 0.2, so it doesn't change. So Q equal mass 4 gram, because we are talking about the same sample, times 0.2, because Cp doesn't change for glass, times the new change in temperature, which is 30, equal 24. What is the unit of Q? If we use the Cp in unit joule per gram Kelvin, so the unit of Q will be joule. Okay? Enthalpy of the reaction. What does enthalpy of the reaction mean? Enthalpy means energy. The meaning of enthalpy is energy. Enthalpy change is the amount of energy absorbed or released during the chemical reaction. This is the enthalpy change. So enthalpy is energy, and the enthalpy change is the amount of energy change, energy absorbed or gained during the chemical reaction. Okay? So enthalpy change is the amount of energy absorbed or gained during the chemical reaction. Any chemical reaction. Okay? Right. The normal chemical equation, as we wrote before, the normal chemical equation doesn't include the change in energy. If the chemical equation includes the change in energy, the amount of energy absorbed or gained, we call the chemical equation, in this case, thermochemical equation. So, for example, thermochemical equation is the equation that includes the enthalpy change. For example, 2H2O, 2H2 plus O2, gas produce 2H2O plus 483.6. Without this number, this is normal chemical equation. With this number, this is thermochemical equation. So the difference between normal chemical equation and the thermochemical equation is this number. If the equation contains ions, for example, without this one, so this is also not thermochemical equation. 5. In thermochemical equation, it has some properties. The first one, that The coefficients in thermochemical equation represents only moles. It doesn't represent molecule because we may use half, quarter, and so on. So coefficient in thermochemical equation represents mole. Number 2, in thermochemical equation, the state, the physical state of substance is important. Why? Because the enthalpy change by the formation of water, liquid, or gas is not like the enthalpy change for the liquid water. Is not like the enthalpy change, for example, for the solid water, and so on. So each state has its own enthalpy. So the state of substance is important in writing the thermochemical equation. Number three, the enthalpy of a chemical reaction is direct proportional to the number of mole. Enthalpy change. The symbol of enthalpy change is delta H. Delta H is direct proportional to the number of moles. Number of moles. How? The enthalpy change, as we said, the difference in energy between the reactant and product. How do we calculate the enthalpy change for certain reaction? The enthalpy change delta H equals the enthalpy of the product minus the enthalpy of the reactant. Any difference equal the difference between, in a chemical reaction, equal the difference between product minus reactant. So the enthalpy change equal the product minus the reactant. We have two ways to calculate the enthalpy change. This is the first rule, and the second rule is Hess law. We will study Hess law by the end of this section, inshallah. How do we use this rule to calculate the enthalpy change for chemical reaction? For example, suppose we don't have this number, and the question is, calculate the enthalpy change for the formation of water, gas from its elements. Example, calculate delta H for formation of H2O gas. We said that the physical state is very important. How can we calculate? What does formation mean? Formation means what? Water is formed. Formed from what? From its element. So delta H of formation, I mean when the substance is formed from its elements. So the first thing that you have to write is the equation. How do we write the equation? Water formed, so water is product, right? Water is product. Formed from what? Hydrogen and oxygen. Now we don't write hydrogen H or oxygen O. In the equation we write hydrogen H2 and oxygen O2. H2 exists in the form of gas, O2 exists in the form of gas. And we need water in which state? Gas. H2 plus O2 produce H2O. This is the first step. Like this equation, this is the first step. The second step, is this equation balanced? We have to balance the thermochemical equation. H2 plus O2 produce H2O. We have two balancing for this equation, and both of them right. The first one, you can put 2 H2 plus O2 produce 2 H2O, and this is right. And we can also put H2 plus half O2 produce H2O, and this is also right. Because we need this equation, so we need this balance, or this kind of fraction. Okay? Type. How can we solve this? Delta H, or the enthalpy change, equal product minus reactant, right? Product, this is the product, minus reactant. Delta H for any pure element equals 0. So delta H for pure element equals 0. How can we get, so delta H of H2 equals 0, and delta H for O2 equals also 0. We need delta H for water, for H2O. How can we get delta H for H2O? From table or given in the exam. Okay? Alright. H2O from the table, delta H for water equals negative about 243. Delta H of 1 mole of water equals 241.8. Delta H for H2O gas equal 241.8 kilojoule. 241.8 kilojoule. So this is the delta H of the reactant, and this is delta H of what? Of the product. Delta H of water, sorry, is equal negative this number. طيب, how can we calculate delta H? يبقى delta H equal H of the product, which is 281.8. This is for how many moles of water? Delta H given in the table is only for 1 mole, called the molar enthalpy change, or the molar enthalpy change of formation. Delta H that you get from any table or from any standard for 1 mole. So negative 281 is the delta H for 1 mole of water. How many moles of water do we have? 2. And according to this property, delta H is direct proportional to the number of moles. So we have to multiply this number times 2. Why times 2? Because we have 2 moles. Minus delta H of the reactant, which is 0 plus 0. 0 of hydrogen, because the delta H for hydrogen 0, and delta H for oxygen 0. So delta H for this reaction will be negative 483.6. Negative 483.6. The unit of delta H, as we said, delta H is energy. The unit of delta H is kilojoule. Right. This is delta H for this reaction. Delta H for this reaction. But how can we put delta H in the equation? We know now the number or the energy change is negative 483. How can we put this number in the equation? To put this number in the equation, first you have to know the time of the reaction. What does the time of the reaction mean? Delta H for any chemical reaction, delta H for any chemical reaction may be negative or positive. Negative or positive. If delta H is negative, so the reaction is exothermic. You know what is the difference between exothermic and exothermic and endothermic? If delta H is negative, so reaction is exothermic. If delta H is positive, so the reaction is endothermic. What is the difference between them? قول بسرعة. عامل لي مشكلة، الناس مش راضية عايزة تدخل في صلبة. مين اللي عايز يدخل في صلبة؟ اللي هو عايز يخش خالص، والناس اللي عامل طلب كله مسرح. مش راضيين. مش راضيين عشان الفصل مش هيكفي، عشان بسجل بس. طب أكمل بعدين. If delta H is negative, so the reaction is exothermic. Delta H is positive, the reaction is endothermic. Endothermic. What is the difference between exothermic and endothermic? Exothermic reaction is the reaction that releases heat. Exo means the heat is released. Endothermic reaction, the reaction that needs energy. So, reaction absorb or needs energy. Why the exothermic reaction releases heat and the endothermic reaction absorbs heat? Or what is the difference between endothermic and exothermic? in the exothermic reaction, you know that for the reactant, they have energy, while product, they have energy, right? In the exothermic reaction, the energy of the reactant or the enthalpy of the reactant is greater than the enthalpy of the product. So if this is the enthalpy or energy of the reactant, this is the energy or the enthalpy of the reactant, and this is the enthalpy of the product. The enthalpy of the product is less than or greater than the enthalpy of the reactant. As you see, the enthalpy of the product is less than the enthalpy of the reactant. And we said that delta H equals H of the product minus H of the reactant. So delta H will be negative. So delta H negative because the energy of the product is smaller than the energy of the reactant. This is energy and this is the reaction progress or course of the reaction. Reaction progress. In this case, because the energy of the product is less than the energy of the reactant, so the difference between them will be delta H, and its value is negative. Okay? In this case also, because the energy of the product is lower than the energy of the reactant, so the product in this case is stable because the energy is lower than the energy of the reactant. Opposite of this, for the endothermic reaction. For the endothermic reaction, the energy of the reactant is less than the energy of the product. This is the enthalpy of the reactant, and this is the enthalpy of the product. The difference between them will be delta H, as you see, because the energy of the product is greater than the energy of the reactant, so the difference should be positive. In this case, this reaction needs heat because the energy of the reactant is low, so it needs heat to reach to the energy of what? The energy of the product. Type. How can we write delta H positive or negative in the thermochemical equation? In the previous example of water, delta H for 2H2 plus O2 produce 2H2O, gas, and delta H equal negative 483.6 kilojoule. How do we write this value in the reaction? If delta H is negative, so the reaction is exothermic. Exothermic, I mean the energy in the product or reactant in the product. So we should write this value in the product because this value or this reaction is exothermic reaction. To make this, so 2H2 plus O2, gas, produce 2H2O, gas plus 483.6. This is the thermochemical equation for the formation of 2 moles of water. From the properties of the thermochemical equation, that if you reverse the reaction, the reaction changes from exothermic to endothermic. The reaction changed from exothermic to endothermic. Ooh.
It's supposed to be negative?
This one negative, yes, but when you put it in the equation, we put it plus. The negative value here means that this amount of energy is released. So it exists in the product. So we add them to the product. You know? So if you put this value in the chemical reaction, in all of cases, positive. Plus. But plus in product or plus in reactant depends on the value of, or the sign of delta H. For example, if you reverse the equation, so it will be 2H2O gas plus 483.6 equals 2 H2 gas plus O2 gas. This reaction is exothermic. So this reaction, the opposite or the reverse reaction, is endothermic. In this case, delta H equal positive 483.6 kilojoule. And this is also one of the properties of the thermochemical equation. Okay? Right. This is the difference between endothermic reaction and the exothermic reaction. If the question is, this example, for example, this equation, for example, is for exothermic or endothermic, if the energy exists in the product, so the reaction is exothermic. If the energy exists in the reactant, so the reaction is endothermic. طيب. As we said that the energy or the enthalpy change is direct proportional to the number of moles, right? Do you know how to calculate the number of moles? Do you remember how to calculate the number of moles? Mass over molar mass. We have triangle mass, mole, molar, mass. If the question, for example, calculate the enthalpy change by the formation of 9 gram water, how do we use this? How do we make this? If the reaction, for example, is 2H2 plus O2 produce 2H2O plus 483.6, calculate the enthalpy change for 9 gram H2O. How do we make this? You know that we can't calculate for certain grams. We have to change it into moles because we said that the number or the enthalpy change direct proportional to moles. So 9 grams mean how many moles of water? Moles of water equal 9 over mass over the molar mass. طبعا the molar mass of water is 2 plus 16 equal 2 plus 16 equal 18. 9 over 18 equal 0.5. 0.5 mole or half mole. If this equation is given, for example, so the 2 moles produce 483.6. So 1 mole produce 241.8, or if delta H, if this number is given, delta H for water, gas equal negative 241.8, calculate the delta H for 9 gram. So if the delta H produced from 1 mole water is negative 241.6, so how many, or what is the amount of energy produced by 0.5 mole of water? So this number over 2. So delta H for 0.5 mole equal negative 241. عليكم السلام ورحمة الله وبركاته. 241.8 over 2 equal number kilojoule. اي حد اثنين يعني؟
لا واحد.
ما نفضلي اي حد ماشي نفضل ماشي ينفع. لا ينفع، لا مش هيجي، ما اعرفش، لو مش هيجي مش تفضلوش. طيب فضي حد هيجي.
رضوان
لا بلاش، فضي
خد رأيه الاول. طيب اشوف الاول.
خد رأيه ماشي.
خد رأي رضوان وفضيه.
ما رضوان كده عنده حصص قليله.
عنده حصه.
لا بص، خليه فضي لي حد تاني، زايد او رفعت، لو رفعت هيجي. لو رفعت
مش موجود برضه.
خلاص فضي لي زايد. فضي زايد. delta H node, this means molar enthalpy change. And this is for 1 mole. For 1 mole. Delta H node F, this is formation of 1 mole. The enthalpy of formation of 1 mole. Delta H C, this is combustion of 1 mole. We know formation, right? Enthalpy of formation when substance is formed from its element. What is combustion? Combustion is when substance is burned in the presence of oxygen. For example, if CH4 gas reacts with oxygen gas to produce CO2 plus H2O. Delta H of CH4 in this case, O2. Delta H for CH4 in this case is called enthalpy of combustion. Because in this equation, methane is burned in the presence of oxygen to produce carbon dioxide and water vapor. By the way, the combustion of any organic substance I mean substance contain carbon and hydrogen. Combustion or burning any organic substance produce carbon dioxide and water vapor. Gas and liquid. Okay? So if the question is the combustion of propane, C3H8, the combustion of butane, C4H10, whatever, the combustion of compound that contain carbon or hydrogen always produces carbon dioxide and water vapor and balance the equation. طبعا to balance the equation of the combustion, it is better to start balancing of carbon atoms first, then balance the hydrogen atoms, then balance the oxygen. Balance carbon, then balance hydrogen, then balance oxygen. Example, C4H10, this is butane, plus oxygen. Produce what? Produce what? CO2 plus H2O. CO2 plus H2O. How do you balance this equation? First step, balance the carbon atoms. We have 4 carbons. How many carbons here? 1. So multiply by 4. Balance hydrogen. 10 hydrogen and 2 hydrogen. Multiply the number of hydrogen times 5. Okay? So the carbon and hydrogen are balanced. How do we balance O2? In a 4 times 2? 8. 5 times 2? 5 times 1, 5. 5 plus 8, 13. So we put before oxygen 13 over 2 or 6.5. This is okay in the thermochemical equation. 13 over 2 or 6.5 moles of water, of oxygen. This is to balance the equation after forming this equation, because maybe the question is calculate the enthalpy change by the combustion of methane to form carbon dioxide and water vapor. The carbon dioxide and water vapor will enthalpy of CH4 is given. So you have to subtract this one minus this one, right, to calculate delta H. To subtract, you have to know the number of moles, because as we said, the delta H for water is negative 280, for example, for liquid water. So you have to multiply it by 2. Okay? To make or to work on any equation in thermochemical equation, the equation should be balanced. Okay? طيب. So the delta H, we have H of formation, H of combustion, and the H of solution. Enthalpy of solution, enthalpy of combustion, enthalpy of formation. You took in chapter 13 the enthalpy of solution, the 3 steps of dissolving, if you remember. We have now in this question, or in this section, we'll talk about the enthalpy of formation and enthalpy of combustion. Okay? Enthalpy of formation, if the substance is formed from its element. يعني for example, enthalpy of formation of SO2, I mean S plus O produce S plus O2 produce SO2. Enthalpy of formation of CO2, so I mean C plus O2 produce CO2. This is called the enthalpy of formation. Enthalpy of combustion, when the substance is burned to produce carbon dioxide and water vapor in case of organic compounds. طيب. plus what؟ plus الانثالبي ده يبدا انثالبي جيفن، لكن هنا بقول لك بس ايه؟ This is called the combustion. This is not thermochemical equation. This is combustion. If the question is calculate the enthalpy of combustion, so you have to make the equation first. This is how to make the equation. Okay? formation اصلا يبقى الدلتا اتش بتاعته واحده. whatever delta H of formation or combustion تبقى واحده. Okay? لكن combustion if the substance is broken down to produce something else. طيب. The second way to calculate the delta H. So we have two ways to calculate the delta H. The first one by subtracting delta H of the product minus H of the reactant, and this is how. The second one is use Hess law. Before knowing Hess law, can we make relation between formation and combustion? يعني if, for example, the question is delta H of formation of substance is X. Delta H of formation of substance is X. And delta H of the combustion, and the delta H for the product of the combustion of the same substance is Y. How do you calculate the enthalpy change of the combustion? Again, if delta H for the formation of X is delta H of the formation of certain substance is X. Okay? Calculate the enthalpy of combustion of this substance if delta H of its product is Y. How do we calculate the delta H of combustion? Delta H of formation of substance is X. Calculate delta H of combustion of the same substance if total delta H of its product is Y. How do we make this? For example, if the substance is Z plus F equal ZF. So delta H formation in this case equal X, right? But combustion of substance. Combustion of substance, I mean this substance, ZF. Combustion, I mean reaction with oxygen, right? Produce whatever, produce what? For example, produce ZO plus FO. For example, delta H of its product is كذا. So delta H for this product is Y. How do we calculate delta H of combustion of this substance? So delta H for ZF is X, right? Delta F for ZF is X, and delta H for the product is Y. How do we calculate the delta H for the combustion? I mean the delta H for this reaction, right? So delta H of the product minus the reactant. طبعا combustion I mean reaction with oxygen. What is the enthalpy of oxygen? This is not given. What is the enthalpy of oxygen? The enthalpy of oxygen equals 0. So x plus 0x. So the delta H of combustion in this case is y minus x. Okay?
The enthalpy of formation X or reverse X.
The enthalpy of formation. No, we didn't reverse this equation. This is a new equation. Yes, okay, but this is new equation. يعني delta H, if for ZF is negative, it will be negative. If positive, it will be positive. Delta H, we reverse the sign if we reverse the same reaction. Here, we didn't reverse the reaction. Delta H for certain substance is the same, doesn't change. So the second one is not the reverse of the first one. So this is why we can't reverse the sign. طيب, the second way to calculate the delta H is using Hess law. We use Hess law if the reaction doesn't happen in one step. What does it mean? And if the reaction happen in more than one step, Hess law states that to calculate the overall enthalpy of certain reaction, we get the sum of delta H of the individual steps. This is Hess law. Hess law states that the overall delta H or enthalpy change of a chemical reaction equals the sum of delta H of individual steps. How can we use the Hess law in calculating the thermochemical equations? Example. Calculate the delta H for the formation of methane from its elements. Calculate delta H. This example, page 519 in the textbook. Calculate delta H for C solid plus 2H2 gas produce CH4 gas, and delta H equal unknown. Calculate delta H in this case. The steps of this reaction are C plus O2 produce CO2, and delta H equal negative 393.5 kilojoule. H2 gas plus O2 gas produce H2O liquid, and delta H equal negative 285.8 kilojoule. Delta H or CH4 gas plus 2O2 produce carbon dioxide plus 2H2O, and delta H equal negative 890 kilojoule. How do we calculate the overall enthalpy of this reaction? To calculate the overall enthalpy of this reaction, we have to add the enthalpy of this reaction, as Hess law said. To add the enthalpy of this reaction, we have to add these reactions together. We should get this equation after adding these two reactions to add delta H to get this one. Again, to add these three delta H's, you have to add the three equations. After adding the three equations, you should get this one. In this case, you can add the 3 delta H to get the overall H. How? We have to modify the three equation to be like the main equation. Again, we have to modify these equations to be like the main equation. So you should have main equation and steps that lead to this equation. Type. How do we modify this? Number one, look at the main equation. What do we have? For example, one carbon atom, one mole carbon, and 2 moles hydrogen. These are reactants, and 1 mole methane. This is product. We should change the amount of carbon in this equation to 1 mole if it is not 1 mole, and change it to reactant if it is product like the main equation. Carbon, 1 mole reactant. The equation that contains carbon, this one. We have 1 mole carbon and the carbon is reactant, so the first equation we use it as it is. But the first equation C solid plus O2 gas produce CO2, and delta H equal negative 393.5 kilojoule. The second equation contain H. How many H in this reaction? 2. In the main equation we have 2. So we have to, and the H is reactant. So we have to modify H in the equations as reactant and 2 moles. In this one, how many moles do we have? We have 1 mole. So we have to multiply the second equation by 2 and write the new equation. 2H2 gas plus 2O2. Sorry, we have here half O2, I think. Half O2. H2 plus half O2, not 1 O2. Two times half equals 1. So H2 plus O2 gas produce H2O liquid. Delta H equal negative 5.8 multiply 2. 2H2O. 2H2O. 2 multiply 2. 2 multiply 1, 2. 2 multiply half 1. 2 multiply 1 equals 2. The third one contains CH4 in the main equation. CH4 is product and its number is 1. In this equation that contains CH4, reactant and its number is 1. So we have to reverse or flip equation number 3. Flip equation 3. When we flip equation 3, it will be carbon, equation 3, carbon dioxide plus 2H2O gas liquid equals CH4 plus 2O2, right? And delta H in this case, as we said, if you reverse the reaction, delta H will be positive and negative. So delta H equal 890 kilojoule. To check the validity of these 3 reactions, we should get this equation after adding this reaction, after modification. How? How do we add the equations? So can we multiply an equation and flip it? Can we make more than one process in the same equation? Yes, we can. We can make more than one effect in the same equation. Type. How do we add these equations? If the compounds exist in the reactants, we add them. And for example, one oxygen, there are 2 oxygen in the reactant. If we have a compound that exists in the reactant and product, we cancel them. We consider them positive and negative because this is produced by reaction and consumed in the first reaction. Though the total is 0. طيب, adding this equation, the first equation contains carbon, no other carbon, so carbon exists in the reactant, plus O2, O2, there are two O2, and we have two O2 in the product. We cancel them together. 2H2, no other 2H2 exists, so 2H2 gas produce. So we took 2H2. Carbon dioxide. Do we have other carbon dioxide? We have one. Cancel them together. H2O. We have 2H2O and 2H2O. Cancel H2O with H2O. So carbon plus 2H2 produce CH4. CH4 gas. After adding this equation, if you get the main one, so now you can add these two numbers. These two numbers. Add them using the same signs. So delta H equal, delta H total for this reaction equal negative 393.5 plus 2 multiply negative 285.8 plus 890 equal negative 74.3 kilojoule. So in this case, the reaction is exothermic because delta H is negative. Delta H is negative. يا وائل وائل
انا قلت احمد خميس يبدلها السبعه ما كانت تامنه.
مش حاجه قدامي.
قلت له هو يبدلها لي ويجي يقول لي عشان انا هنا مش هينفع اقف عشان بسجل، فقلت له يبدلها لي فروح اساله معلش.
شكل انت عامل لي فيها فضل شاكر. يا البومك الجديد ده مثلا.
So delta H equal negative 9 negative 74.3. طيب, the steps. No. The equation is, or the question is, calculate delta H. So this is delta H. Okay. If the question is put the delta H, ya Kareem. If the question is rewrite this equation including the enthalpy change, so you have to put this one in the product. Okay. طيب, the steps of the reaction may be given as steps like this, or in the form of curve or diagram. In case of diagram, how do we get the steps from diagram? Example, enthalpies of the reaction, C plus O2, solid, gas, 0 kilojoule, because we said that the elements, the enthalpy change of elements equals 0. The second step, C plus half O2, CO plus half O2, CO gas plus half O2, gas, delta H equal negative 110.5 kilojoule. The third one, CO2, gas, and delta H equal negative 283, negative 283 kilojoule. How do we use the diagram? How can we use this? I'll explain. How do we use this? To get reactions, to get steps of reactions. If the question, for example, find the if the question is what is the enthalpy change if carbon react with oxygen to produce carbon dioxide, how do we get this direct from the curve? Carbon react with oxygen to produce carbon dioxide. The sum, this part, because this part represents the energy released when carbon react with oxygen to produce carbon dioxide plus carbon monoxide plus half O2. If this is the reaction, so this is delta H. If the reaction is calculate or find or get the value of delta H or the enthalpy change, if CO react with half O2 to produce CO2, we can get it direct from the equation. Okay? Equal negative 2A3. If the question is find delta H, if CO2 produce CO plus half O2, so delta H will the same number but opposite sign. The same for this one. Okay? طيب. The question is calculate delta H for this reaction. C solid plus half O2 produce CO. Calculate delta H of formation. Can we get this one direct from the diagram? No, we can't. It doesn't exist. C plus half O2 produce CO. We don't have this on curve. So how can we make this? We can get this by making equation. How many equations do we have on this curve? 1, 2, 3, right? 1, 2, 3. How can we get two equations to calculate this one? If the first equation and this equation, listen, how do we think about this reaction? If this is the first equation, okay, and this is the second equation, for example. So the second equation we have CO2. Do we have CO2 in the main equation? Do we have CO2 in the main equation? No, we don't have. So you have to choose at least two equations, right? The two equations consist CO2 to cancel them together, right? One of the equations should contain C and the other equation should contain O2. So we have to get two equations. One of them, the two equations should contain CO2 to cancel it together, okay? And the equation should contain C and O. طبعا we can get this from which? What are the two equations from the curve that have CO2? This is the first and this is the second, right? So the first equation, C plus O2, C plus O2, C solid plus O2 gas, produce CO2, and delta H in this case equal the sum of this one equal negative 393.5 kilojoule. The second equation that contains CO2 from this part to this part, CO plus half O2 produce CO2. This is the second equation. But in the first reaction, CO2 is a product. Can we get another equation that contains CO2 as a reactant? Yes, move from this part to this part, opposite. So the second equation is CO2 produce CO plus half O2, and delta H in this case equals positive this number, equal 39283 equal 283 كيلو
حسيتنا دلوقتي.
ايوه انا بدلت حسكم مع التامنه. سيد مستر احمد خميس هخش لكم التامنه مكان دي. قولي مستر احمد خميس. اوكي يا رجاله؟ طيب and these two equations C, we don't have C, right? C solid plus, if the same compound is common in the equation, if the same compound that you need in the main equation, this is the main equation, right? If the same substance that you need exists in the two equation, leave it. Leave it. يعني finish the other reactants or products. Okay? يعني O exists in both equation. Leave it. طب modify the others. How many carbon do we need? 1 carbon as a reactant. طب this one contain 1 carbon reactant. So we will use the first equation as it is. طب what about CO? How many moles of CO we need? 1 reactant or product? Product. 1 in the product. So we will use the two equations as they exist. C, we don't have other C, so C plus O2, 1 and half O2 in the product. Sum 1 minus half equal half in the reactant, right? Equal CO2 and CO2, we will cancel them, equals CO. In this case, we can add delta H equal negative 393.5 plus 28 equal number kilojoule. Okay, this is how to use the diagram to solve this equation. Right. So the diagram, we can get steps to solve the equation, or we can get the delta H direct from the curve. Yeah, if the equation exists in the diagram. Okay? طيب. Do we have relation between the stability of the compounds and the value of delta H? Yes, we have relation between the stability of the compound and the value of delta H. For example, if delta H for certain reaction equal negative 900 kilojoule, and delta H for other reactant equal negative 500, delta H for the third reaction equal positive 100, and delta H for other reactants equal positive 600. Which reaction give the most stable products? Which reaction give the most stable product? The reaction that has the highest negative value produce the most stable product. Because the highest negative value, it means the difference between reactant and product is very high, so the energy of the product is very low, so the reaction in this case is or produce very stable product. So this one produce most stable product. This one, which one produce the least stable product? The highest positive. The least stable product. And which one of them is higher stable than the other? The negative value always stable, more stable product than the positive value. So this one is more stable than this one. This one is stable, and this stable. Okay, so as the negative value increases, the stability of the product increases. As the positive value increases, the stability of the product decreases. طيب. Positive, more stable product. This means that the reaction is favorable or not favorable? Favorable. If the products are stable, so the reaction is favored in this case. And delta H is negative. So if delta H is negative, so the reaction is favored because it forms more stable product. If delta H is positive, so we produce less stable product, so the reaction in this case is not favorable. Favorable action, we call it spontaneous reaction, and not favorable reaction, or the reaction that produce less stable product, is called non-spontaneous reaction. Spontaneous reaction means the reaction that happen very fast without any external help or little external help. Both of them right for the spontaneous reaction. Non-spontaneous reaction that needs external energy or external help to happen. Okay? This is the difference between spontaneous and non-spontaneous. So if, for example, for a chemical reaction, its delta H is negative, so this reaction is spontaneous. لا دلتا ودلتا اتش، هو الدلتا جي في الاخر. Concerning delta H, if delta H is negative, so the reaction is according to enthalpy change spontaneous, and according to delta enthalpy change is not spontaneous. We have another force or another factor that determine if the reaction is spontaneous or non-spontaneous. The second factor is delta S. Delta S or S, you know that S is called the entropy, right? S is entropy. And delta S is entropy change. Right. You know that what does entropy mean? Entropy is a measure of disorder or randomness or chaos of the chemical reaction. This is the disorder. طيب. If we change the substance, for example, from solid to liquid, so its entropy increases, S increases, and delta S in this case, delta S change in entropy also is the entropy of the product, something produced minus reactant. If the entropy increases, so delta S is positive, right? If gas change into liquid, gas more randomness, right? Liquid more ordered or less randomness. But S in this case decrease and delta S is negative. Solid dissolved in liquid increases entropy or decreases entropy? Solid dissolved in liquid increases entropy. Solid to liquid increases entropy. Liquid to gas increases entropy. The opposite decreases entropy. Mixing gases increases entropy. Increasing number of moles of gases increases also entropy. طيب. The natural process tend to increase entropy or decrease entropy. Any natural process tend to increase entropy. For example, if you have piece of ice and leave it in the room temperature, it will melt. Melt, you mean increasing entropy. If you spread water on earth, so the water will evaporate. This is also increasing entropy. So most of the natural process in air, in the universe, tend to increase entropy. So if delta S is positive and delta S is negative, delta S is positive, this will happen spontaneously or non-spontaneously. This will happen spontaneously because we said that the natural process tend to increase entropy. يعني delta S is positive. So if delta S for certain reaction is positive, so the reaction is spontaneous. If delta H is negative, so the reaction is non-spontaneous. So if delta H is negative and delta S is positive, the two factors together control the overall reaction is spontaneous or non-spontaneous. Delta H and S together control the reaction is spontaneous or non-spontaneous. If delta H is negative and delta S is positive, so the reaction is spontaneous. If delta H is positive and delta S is negative, so the reaction is non-spontaneous. But what about if delta H is negative and delta S is negative, or delta H is positive and delta S is positive? In this case, we cannot determine the reaction is spontaneous or non-spontaneous by knowing delta H alone and delta S alone. One of the scientists solved this problem. Gibbs. He made a new quantity called Gibbs free energy. Gibbs free energy is a quantity, Gibbs free energy, delta G. Gibbs free energy is the quantities that combine delta H and delta S to know overall if the reaction is spontaneous or non-spontaneous. Delta G equal delta H minus T delta S. This is the rule. This is combination between delta H and delta S to get the value of delta G to know if the reaction is spontaneous or non-spontaneous. طيب, if delta H is negative and delta S is positive, delta H is negative and delta S is positive, we said the reaction is what? What is the value of delta G in this case? Positive times negative, negative, negative plus negative, negative. So if delta G is negative, so the reaction is spontaneous. But if delta S is negative and delta H is positive, negatives times negative, positive, positive equal positive. So delta G positive, the reaction is non-spontaneous. Type. If both of them are positive, delta H positive with delta S positive, when this value becomes negative, positive and positive, when this value becomes negative, if this value is high, right? If this one is positive, delta H, delta S, delta G, delta H is negative, delta S positive, delta G will be negative and the reaction is spontaneous, right? If delta H is positive, delta S is negative, so delta G is positive and the reaction is not spontaneous. If delta H is positive and delta S is positive, this one positive and this one positive. So when the reaction becomes spontaneous or delta G negative? If this value is high. When this value becomes high, when the temperature is high, so if this one is positive and this one is positive, the reaction will be spontaneous at high temperature. At high temperature. So negative or spontaneous at high temperature. طبعا if negative and negative, negative and negative, negative times negative positive, so this value should be high, so the temperature should be low. So negative and negative, the reaction is, our delta G is negative at low temperature. The reaction is negative at low temperature. This is how to predict the reaction is spontaneous or non-spontaneous at high or low temperature. The questions or the problems on this reaction is given the value, if the value of delta H is given, the value of delta S is given. نعم؟ قول
بس الوش الاولاني ولا
لسه
5 دقايق يعني
ماشي حاضر.
بقول لك
If delta the problems in this case, delta H value given, delta S value given, calculate delta H. We have problem in the textbook. يبقى if delta H is given, delta S is given, it's easy to calculate delta G, right? طيب, if the question as in the textbook, page 550, calculate for the evaporation reaction BR2 liquid produce BR2 gas. Calculate delta G, calculate the temperature at which the reaction is spontaneous if delta H equal 31 kilojoule per mole and delta S equal 93 joule per mole Kelvin, and this is the unit of measuring entropy. How do you calculate? Find the temperature in which the reaction, find T that makes the reaction spontaneous. We have in the equation or in the rule, we have two unknown, temperature and delta G. Both of them unknown in this reaction. We need T, so we should have delta G. طب delta G, the reaction is spontaneous. So delta G, the value of delta G is negative. Spontaneous reaction, so delta G is negative. Right? طيب, what is the negative value that you put to get negative delta G? Below 0, right? Below 0 is negative. So we will find the T that makes delta G equal 0, and above this value, delta G will be negative. So in this case, put delta G equal 0 and solve the problem. Delta G equal delta H minus T delta S. So put delta G equal 0 and delta H equal 31 minus T multiply delta S. Delta S in joule. Delta S in joule. We can't use delta H in kilojoule and delta S in joule. You have to convert delta S into kilojoule. We change joule into kilojoule by dividing over 1000. Okay, so T in this case will equal 333 Kelvin. 333 Kelvin. This temperature makes delta G equal 0. And we need this reaction to be spontaneous. You know, this one positive and this one positive. When the reaction becomes spontaneous? At high temperature. So if you increase the temperature more than 333, so the reaction will be spontaneous. Yani if temperature more than 333, the reaction is spontaneous. Type another question in the textbook in the standardized tests. For example, if for the reaction which diatomic molecule dissociates into atoms, N2 gas dissociates into 2N gas. The question is, find what are the signs of delta S and delta H for this reaction or for this change. What is the sign of delta H and delta S? Delta H negative and delta S. طيب, delta S positive. Why? Why the entropy increases? Oh, delta S is the entropy. Why the entropy increases? Bravo. Because we have here 1 mole and we have here 2 moles. So the entropy increases. But what about delta H? Not negative. Positive. Why positive? Because we have many reasons. The first one, for example, we have here bond between N and N. To get to N and N, you have to break this bond. Type to break this bond, and you then form a bond in the product. So you need energy to break this bond. So the reaction is endothermic, and delta H is positive. Need energy. يعني endothermic reaction. And delta, or you know that the bonded atoms and non-bonded atom, which one have higher energy? Sorry, Karim. The bonded and non-bonded, which one has higher energy? The non-bonded, because the bonded atoms, they are stable, right? Any bonded atoms, they are stable because they made bond. Like without bonding, the atom need to make bond, so they have high energy. يبقى the non-bonding atom have higher energy than the bonded atoms. So the product have higher energy than the reactant, so the reaction is endothermic and delta H is positive. Again, bonded atom, non-bonded atom. The atom form bond to be stable. In general, the atom form bond to be stable. So the bonded atoms are stable than the non-bonded atoms. طب stable يعني they have low energy. Non-bonded they have high energy. So this one have low energy and this one have high energy. low energy reactant, high energy product. This is endothermic or exothermic? Endothermic. So delta H is positive. Or we need energy to break this bond. So the reaction takes in energy to break this bond. So the sign of delta H is positive and delta S is negative because entropy increase. Delta S is positive, yes, because the entropy increase. Because 1 mole produces 2 moles. Mixing gases increase. So the entropy increases. This is chapter 16. Inshallah, next time we'll finish chapter 18. Yes, wait.